Picture this, it is Monday morning, your lead drops a messy Python loop in your lap. It works on 1,000 rows, it dies on 10 million. You have got 2 hours before the demo. This is where Claude earns its seat. It can draft a transformation, decode an ugly stack trace, and refactor that loop into clean Spark. If you drive it well, but here is the catch, it can invent an API that does not exist or quietly trigger a huge shuffle. So you verify, you do not paste and pray. By the end, you will have a prompt recipe, two real before and afters, and the guardrails that keep Claude honest. Take a look at the loop you are about to live in. You give Claude three things: your intent, your schema, and your dialect, which is PySpark on databricks. Claude drafts the transformation in seconds. Then you read it, you run it on a small sample, you check the result, and you check the Spark UI. And then you iterate. Think of it this way: Claude is the fast hands, you are the reviewer who ships it. The verify step in the middle is the one you never skip. Here is the mental model that keeps you safe. Treat Claude like a brilliant, fast junior Spark engineer, not an oracle. It writes a strong first draft in seconds, and that draft is often very good. But it can also be confidently wrong. Wrong about a Spark API or wrong about the execution plan, it quietly triggers. So your job changes shape. You spend less time typing Spark and more time reviewing two things: the code itself and the execution it implies. Read both always. So where is Claude genuinely great first? Boilerplate transformations, joins, window functions, pivots, exploding nested JSON, schema cast, the stuff you have written 100 times. Second, refactoring, turning a row by row Python loop or a wide messy UDF into the native data frame, ABOOEPI. Third, explaining things, a cryptic stack trace, an inherited notebook nobody understands, comments and tests. These are the high value plays. Claude saves you real minutes here every single day. Now the prompt recipe, this is the whole game. Give Claude four things: the schema, the dialect, the intent and the constraints. Dialect means PySpark on databricks. Say it explicitly. And constraints are where you teach it to respect the cluster. Things like use the data frame API and no UDF, or avoid a full shuffle, or broadcast the small table. Here is the rule to remember: a vague prompt gives you vague Spark. A specific prompt gives you a draft that respects the cluster. Watch the recipe in action. Your prompt reads like this: PSpark on Databricks orders has order ID, customer ID, order timestamp, and amount. Customers has customer ID and region intent. Total amount per region. Over the last 30 days, customers is tiny, so broadcast it. Data frame AYPI, no UDF. Claude returns a readable chain. Filter, then a broadcast, join, then group by, then aggregate. And when it is not quite right, tighten the prompt, not the code. You iterate at the intent level, that is the trick. Here is the first real before and after, the Python loop before. Someone collected the rows into the driver and looped over them in plain Python. They wanted to flag each customer's first order. It is slow, it is single node, and it breaks at scale. After Claude rewrites it with row number partitioned by customer ID, ordered by order timestamp, where the rank equals 1. Same answer, but now it runs across the whole cluster and Catalyst can optimize it. This is the classic loop to data frame refactor. Learn to spot it. You will use it constantly. Second, before and after, decoding a Spark stack trace. You have all seen it, a wall of red, and the line that actually failed is buried under Java and py4j frames. So you paste the whole thing and ask one question: PySpark on Databricks. What is the real cause of this stack trace and how do I fix it? Claude points straight past the noise to the root. In this case, an analysis exception, a column that does not exist anymore because a join renamed it. Minutes of squinting gone in seconds. Third, before and after, and this is the expensive one: skew and shuffle. Before you join on a key where one value is 90% of the rows. So a few tasks run forever while the rest sit idle. You describe the symptom to Claude: one straggler task and a massive shuffle right. Ask it to read that and propose a fix after. It suggests broadcasting the small side or enabling adaptive query execution skew handling. But here is the rule: you confirm it in the Spark UI. Claude proposes, the UI decides. Now the guardrails, because Claude is not magic. First, it can hallucinate an API. It may invent a data frame method, a function, or an option that simply does not exist in your Spark version. Second, and this one is sneakier, it can write perfectly valid PySpark that returns the wrong answer, or that triggers a giant shuffle you never asked for. So burn this into your head. Confident output is not correct output. Assume nothing until you have run it and read the plan. That is the whole job. So how do you verify? Two things every time. The result and the plan. First, run it on a small sample. Use df.limit of 1000 or a dev table. Never blind on the full dataset. Then check the result, the row count, and a few actual values against what you expected to see. Then read the plan. df.explain and the spark you, I did it broadcast the small table like you asked, or did it trigger a full shuffle and a spill to disk? The plan tells you the truth. Let us zoom in on the A by PI check because this one is fast and saves you before you trust an unfamiliar method. Run it on a tiny data frame. If it is not real, it errors instantly. No harm done. Next, cross-check the method name against the docs, and not just any docs, the docs for your Spark and Databricks runtime version. And if Claude cites an option, confirm it is valid for your version too. APIs differ across Spark releases. What is real in one runtime is a hallucination in another. Here is a use you will love, explaining inherited notebooks. You just inherited a 600-line notebook of chain transforms. Nobody on the team remembers writing it. Paste a cell and ask explain what this does step by step. Then go deeper. Ask what this notebook outputs and what would break if the input schema changed. Claude is often faster than reverse engineering it yourself, and it is a gift when you are onboarding to a messy repo, understanding before you change anything. That is the move. Claude is also great at the chores you skip. Documenting and testing, have it generate doc strings, a transformation step summary, and column level lineage notes for a notebook. Then ask for the edge cases you would miss. Nulls, duplicate keys, empty partitions, late arriving data, schema drift. Claude is good at naming the failure modes you forgot. And finally, have it draft a small assertion. Using Chispa or PySpark test, comparing your expected data frame against the actual one. Tests you would never have written by hand. Now you have them. Now the anti-patterns, the ways people get burned. Wrong number 1. Pasting Claude's PySpark straight into a production job. No read, no sample run, no explain. Wrong number 2, and this is serious. Pasting real credentials, tokens, or a Databricks secret into a prompt to make it work. Never do that. Wrong number 3. Shipping a transform whose result you never validated and whose shuffle cost you never checked. Every one of these trades a few saved minutes for a real incident. Do not be that engineer. Let us be honest about the trade-off, speed versus review. The speed up is real. Drafting and debugging genuinely get faster with Claude. But reviewing the code and the plan is non-negotiable. And here is the good news. The net speed up stays large anyway. Reviewing good PySpark beats writing it, cold, and Claude is fast on stack traces. But skip the explain and the Spark UI check, and you trade a few minutes saved for a multi-hour job, and a surprise bill minutes saved, hours lost. Bad math. So where does this fit in a real team? Picture the pipeline. A spec comes in, Claude drafts the transform, the engineer reviews the code and the plan, then tests, then ship, AYI compresses the draft and the debug steps, and it lifts everyone. Juniors level up faster with stack traces explained on tap. Seniors move faster too, with less boilerplate and quicker refactors. But notice what does not disappear. The reviewer role in Spark, it gets more important because the plan matters as much as the answer. Let us put the whole thing on one card, your workflow reference. The prompt schema plus dialect of PySpark on Databricks plus intent plus constraints. Things like no UDF, broadcast the small table, avoid a full shuffle, then draft and then verify. Small sample, check the results, read df.explain and the Spark UI for shuffles and skew, great for transforms, refactors, stack traces and docs, never for blind paste, secrets in prompts or unverified plans. Screenshot this slide, it is the whole lesson in one frame. Let us recap honestly. Fast hands, senior eyes, Claude drafts, refactors and debugs. PySpark fast, the loop to data frame win and the stack trace win. Those are real, you saw both. But there are two things Claude cannot guarantee, that an AYPI actually exists in your version and that the execution plan is sane. That part is your job. And df.explain plus the Spark UI are how you do it in seconds instead of hours. Claude writes the draft, you sign off on the plan. So here is how you ship faster without getting burned. Drive Claude with a tight prompt, verify the result and the plan. And your PySpark throughput genuinely jumps. If you want the full picture, go deeper in Claude for data engineers. That is the complete workflow course and the link is below. And subscribe for the Cortex, SQL and Fabric AI videos coming next. One question before you go, what Spark job would you hand to Claude? First, drop it in the comments. I read every one.